Question 1 is a division and it involves decimals. So I like to write my divisions as a fraction so that I can convert them into nicer divisions. So what I'm going to do here is I'm going to times top and bottom by 100, because that is going to make both these numbers not have decimals in. They're going to be integers. So I've changed it to 846 divided by 15. And I'm even going to simplify this. I don't really want to divide by 15. I could, but I can spot that 3 goes into both. I know that 3 goes into 15 because I know my 3 times table. And you can tell that 3 goes into 846 because if you add up the digits, you get 18, and that's in the 3 times table. So that's a little trick to tell you if 3 goes into a number. And 3 goes into 856 283 times. I did that in my head, but I suppose I should show you how I did that. Goes into 8 twice with 2 left over. 3 goes into 24 8 times, and 3 goes into 6 twice. Oh, shouldn't have done it in my head. 282. So never do it in your head is a little tip. And I've now got to divide by 5. What I could do here, I could divide by 5 using the bus stop, or if I double them now, I could do 564 divided by 10. And 564 divided by 10 is 56.4. So lots of ways of doing it. I like to alter the division like that. We could have just straight off divided by 15 if we wanted to, but that answer is 56.4. So if you're looking for different questions, if you go up into the description, I've made the effort of linking to different questions. So if you're after question 10, it will take you straight there by clicking on the link. Here we've got question 2. It's a subtraction. It's 2 mixed numbers. And what I'm going to do is convert them both into improper fractions, so top heavy. The way to do that is we're going to multiply this 8 by 7 to figure out how many eighths we got in total. 7 times 8 is 56. But we've also got those extra 3 that are on top. So we've got 59 eighths. And 2.5 is 2 times 2, which is 4. And then we add on that extra 1 on top, which is 5. So now what we're doing is 59 eighths. Take away 5 halves. And there's lots of ways of doing this. It's just the way I've chosen to do this one. Now, if we add or subtract fractions, they need to have the same denominator. Now, if hopefully we can spot that we don't need to change them both. 59 eighths can stay 59 eighths, but we need to make the second one eighths as well. We can times 2 by 4 to make it into eighths. So it's 59 eighths, take away 20 eighths. Now that they've got the same denominator, we can just do 59 take away 20, which is 39. And 39 divided by 8, we've got to convert it back to a mixed number. It did ask us to do that. 8 goes into 32 4 times, so it goes into 39 4 times. And there's 7 left over because 39 is 7 bigger than 32. So there's our first 2 answers. If you're wondering why there's drawing already on the paper, this is my hint paper. It's available with you in the description or on my website. I'm trying to create these papers that help people if they're getting stuck. So you can use these. If you're doing a paper and you don't know what to do, it might just guide you along a little bit. But they help me to answer these questions as I go through them. Question 3, we're told that the cube has a total surface area of 150 centimeters squared. And we need to find the volume of the cube. So things we need to know. To figure out the volume of a cube or a cuboid, we would times all 3 dimensions together. So let's make up our own cube. If each side was 3, so each edge would have to be the same for it to be a cube. To get the volume, we would do 3 times 3 times 3, which is 27. 3 cubed. Is 27. That's why it's called cubing, because it gives you the volume of a cube. We don't know for this question what each side is, so that's what we got to figure out. And the surface area is going to help us. So we've got to start here. Now, if you're unsure what to do, I do this quite a lot with people. Make up your own cube, and we do have one down the bottom here, and say, right, well, what's the surface area of this cube? So surface area, if you're unsure, is the area of all the faces. Now, a cube has got 6 faces, and they're all the same. Each face is the same shape. They're all squares. So we need to figure out the area of 1. To figure out the area of the front face, well, we do 3 times 3, which is 9. Because all 6 faces are the same, the total surface area, the area of all 6 faces, will be 54. Okay, so we've made up our own cube here. Sometimes you make up the cube that's in the question, but this question has got a surface area of 150. So we now know that each edge is longer than 3. And we also know what to do with 150. We can sort of unpick what we just did. We can divide that 150 by 6 instead of timesing by 6, which we did down here. And that will tell us the area of one face is 25 centimeters squared. To get an area of 25, each side needs to be 5, because 5 times 5 is 25. So we now know that each edge of our cube is 5. So to work out the volume, we're going to do 5 times 5 times 5, 5 cubed, which is 125. So the volume of this cube will be 125 because we figured out each edge was 5. Question 4, we've got a frequency polygon. This is very easy. But my experience is most people struggle because they can't remember what to do. What the whole point of frequency polygon is, you go to the middle of each group. This is group data, so I've already done the first one here for you. But the second one, we go to the middle of the group 5 to 10, so we go to 7.5, and we put a cross for a frequency of 24. That frequency of 24 up there. So you just go along putting crosses. So the next group in the middle, 13, and then 11 in the middle of the next group, and then finally 4 for the final group. Now what we need to do is join these up with a straight line. I haven't got a ruler to hand, so I'm just going to do it by hand. So we join these up, and that is our frequency polygon. Don't join up across the bottom. Don't draw a line connecting these. It feels like we should because of the word polygon, like a shape, but it's just like that. So that is a frequency polygon. Question 5, we've got a Venn diagram. This weird E just means the universal set, which just means that we need to put all the numbers from 1 to 10 somewhere in this diagram, either outside the 2 circles, maybe in this part, or this part. So that's where we got to put all 10 of these numbers. So set A, circle A, is odd numbers. Set B is square numbers. And then in the middle, this middle bit, will be square numbers that are odd. Outside the 2 sets, we're going to put numbers that aren't odd or aren't square. So hopefully we're all confident with what odd numbers are. 1, 3, 5, 7, and 9. The square numbers are 1, 4, 9. The next one would be 16, but we're only doing numbers up to 10. So from this list, there are 2 numbers that are odd and square numbers. So we're going to put them in the middle bit. So 1 and 9 exist in the middle. Left over to go and set B on its own is the number 4. It's a square number, but it's not odd. And we can put the remaining odd numbers, 3, 5, and 7, over here. And now what we've got left to do are all the numbers that aren't odd and aren't square numbers. So 2, 4 was over here, so don't put that outside. 6, 8, and finally 10. So we completed the Venn diagram. We get 3 marks for doing that. What you can do at the end is just double check you've got them all. 1, 2, 3, 4, 5, 6, 7, 9, 10. And then you can be confident you've done it right. It's always worth checking because often people miss one. And then, as quite often with Venn diagrams, it's asking us a probability question about it. As you can see down here from my hint paper, I've already sort of given a clue here. The set B with a dash, let's just draw that. This means not in B. So the probability that a number is not in B, well, it's just how many numbers are not in B. What fraction of the numbers are not in B? There are 7 of them that are not in B. 1, 2, 3, 4, 5, 6, 7. So 7 out of the 10 are not in B. So that's the probability of picking a number that's not in B. 7 out of 10. Question 6, we've got a scatter graph. Describe the relationship between the age and the weight of the babies. So what we've got going on here is a positive correlation. The older the baby, generally, the more it weighs. I think we all get that makes sense. Obviously, you can have a young baby that's quite heavy, but generally there's a pattern. Nearly all of those crosses are within that area I've drawn. So what they're looking for from you here is that you write positive correlation. You're also allowed to say the older the baby, the more it weighs, but positive correlation is the easiest thing to do here. And then we're told another baby has a weight of 5.8 kilograms, and we're going to use the scatter graph to find an estimate for the age of the baby. So what we're going to do is we're going to draw on something called a line of best fit. I'm going to find my ruler first. So a line of best fit is a line that kind of represents the correlation. So it's meant to go through as many points as possible and have an equal amount either side. So everyone will draw it slightly differently. I'm not quite happy with that. I'm going to redraw it. So do this in pencil in your exam. Again, I'm not 100% happy with that. I'm going to go a little bit higher. So this is subjective. There's a little bit of leeway on the mark scheme for this. Not everyone's going to get the same answer, and I'll tell you the sort of range you can be within. So what I'm doing here is I'm coming across from the 5.8, and then I'm coming down. And I'm getting an age there of 3.8 months. Okay. If I check the mark scheme, it will tell us exactly what range we can be within. And it was happy with 2.5 to 4.5. So you don't need to worry too much about how you draw it. I got 3.8, but it could have been anywhere from 2.5 to 4.5. And then we're done. We're on to question 7. Percentage question. So there's a few ways they can ask you percentage questions. My first thought when looking at this was it was reverse percentage. It's not. It's just telling us that the holiday has gone up by 20%, and that 20% is 240. So the price of the holiday before the increase is just what 100% is. And we can go from 20% to 100% by multiplying by something. So how many 20s make 100? Well, 5 20s make 100. So if we times by 5, we get back to the original price. And 240 times 5 is 1,200. You can use various multiplying methods. Sometimes I just like to add them together. If it's not many, 5's probably about my limit. I might just add it up. 5 4s are 20. 5 2s are 10, plus there's a 6th 2 down there, so 1,200. So the price of the holiday before the increase is 1,200. If it's gone up by £240, it's now going to be 1,440, but it's not asking us that. It wants to know what the price before was. And question 8 is a question about pressure. So you're not expected to know the formula for pressure. It's always given to you. Again, you can see from my hint paper here, there's some colours here to help. And I've written here quite clearly, first thing we need to do is figure out the area of the circle. Now you can actually do this without knowing how to find the area of a circle. We can get it based on the volume and the height of the cylinder. So if we look here, to work out the pressure, we're going to divide the force by the area. It tells us that in the formula box. And I can put the 90 in here because we're told the force is 90. So yeah, what we need to figure out is what the area of the circle is, and then we can use that to figure out the pressure. So to calculate the volume of a cylinder, you would do the area of the circle times the height. Now we know the volume is 1,200 and we know the height is 40. So to figure out what the area of the circle is, we can rearrange this. So the area of the circle is the volume divided by the height. So it's the 1,200 divided by 40. And to do this, what I would do is think, right, straight away, cross off a 0 from top and bottom. And then I'm dividing this 4 into 12. 4 goes into 12 3 times. And we have that extra 0 here. So it's 30. So the area of the circle is 30. So we can put that straight down here. So to figure out the pressure now, it's 90 divided by 30. Getting rid of the 0 on the end of both, it's 9 divided by 3. So the pressure is 3. 3 newtons per centimetre squared. And the unit for that is already down here, so we just need to put that 3 on there. Question 9 looks tricky, but actually when you know what to do on these questions, it's really easy. You can solve simultaneous equations by graphing them. No one likes doing it, but if the graph's drawn for you, it's literally just where the two lines cross. That's the value of x and y that works for both equations. So it's when x is 6, and again you can see my hints already on here to show you, and when y is minus 2, that they meet. So that's the value of x and y that works for both. So when graphing simultaneous equations, it's where they cross. If we're not graphing it, it's quite complicated sometimes solving simultaneous equations, but this here is quite easy, and the indication for that is it's only 1 mark. So x is 6, y is minus 2. Question 10, we've got a pentagon. And again, in my hint here, I've said angles in a pentagon sum to what? So you're going to be in trouble on this question if you don't know what angles in a pentagon always add up to. We should be confident that a triangle is 180, a quadrilateral is 360. And the rule here is as you add a side, the angles go up, and they always go up by 180. So if we add 180 onto 360, we'll know what angles in a pentagon add up to. They add up to 540. So that's key to this. And we could probably get some marks potentially without knowing that. But that's the basis for this question. So we're given 3 of the angles. We're given 120, 135, and 110. So my first thoughts here would be, I'm going to add those together. And I get 365. So the angles we know add up to 365. So I'm going to take those away from 540 to figure out what the 2 missing angles add up to. Now it's a non-calculator paper. If you can do that in your head, it's fine. You don't have to show a method. You don't have to do the column method. But with a question like that, it might be worth doing. We would need to borrow. 10 take away 5 is 5. 3 take away 6, again, we can't do, so the 5 becomes 4, and we make the 3 13. 13 take away 6 is 7. 4 now take away 3 is 175. So the 2 missing angles add up to 175. So coming up here, work out the size of angle AED. That's what it wanted, and that is the green angle. So this is ultimately what we're trying to figure out. And we're told it's 4 times the size of angle ABC. It's 4 times bigger than this one. Now I called angle ABC X. It's an unknown angle. We can call it X. And what we can now do is call angle AED 4X, because it's 4 times it. Now we know these 2 angles add up to 175, and we can also add them together as algebra. 4x add 1x is 5x. So those 2 angles as an expression is 5x. As an equation, they equal 175. And now we just need to solve this little equation to figure out what x is. Use the unitary method, which means we divide by 5 because we've got 5 x's. So we've got to divide 175 by 5. You can do that in your head, it's fine. But bus stop method's always best if you're struggling to do it in your head. 5 into 25 is 35. Now, it's really tempting to do this. I do this all the time. It might not be asking us what x is. It might be asking us what the bigger angle is, which it is, isn't it? It was always asking us what angle AED is. So that's equal to 4x. So 4x is, we would now times by 4. 35 times 4 is 140. So the biggest angle, angle AED, is 140. Okay, question 11. I've highlighted the top. I would always sort of tidy up the top and then tidy up the bottom before doing anything here. So, indices question, we've got something in brackets, the 6x to the power of 5, y to the power of 3, and it's all squared. So what we need to do here is square everything. We're going to start off by squaring the 6. 6 squared is 36. Now to square indices, you times the power by what you're squaring here. So we're going to times all the powers by 2. If we were cubing, we'd times them all by 3. So the 5 times 2 becomes 10, and the 3 becomes 6. 3 times 2 is 6. On the bottom, we're going to times these two expressions together. So let's start with the numbers. 3 times 4 is 12. And we're going to add the powers. When we times indices together, we add the powers. It's worth remembering there's a hidden 1 there. So 2 add 1 is 3, so we get x cubed. And when we multiply the y's together, we still add them. 7 add minus 3 is the same as 7 take away 3, so it becomes 4. We would have got some marks for doing this, but there's still more to do because we've now got to do a division. So I'm going to put it back as a fraction. So we need to divide the numbers and we need to know what we do with the indices when we divide. But straight away here, we can do 36 divided by 12, which is 3. And with the indices, when we divide, we subtract the powers. So we're going to take, for the x's, we're going to take the 3 away from the 10 to give us 7. And for the y's, we're going to do 6, take away 4, which is 2. So our answer should be 3 times x to the power of 7, y squared. And here we've got a probability tree. So I've drawn on here the green, I've highlighted in green what it is that fulfills the probability we're being asked. Find the probability that Martha will lose at least one game. So there's 3 ways she can lose at least one game. Now, how a probability tree works, to work out the probability of something happening, you multiply the 2 fractions together, or they could be decimals, along the route you're going. So the probability that Martha loses both games is 3 out of 8 times 7 out of 9. So she will lose both games 21 out of 72 times. Okay? So we want the probability Martha will lose at least one game. So that includes losing all of them or losing one game. So here we would do 3/8 times 2/9, which is 6 out of 72. And the probability she wins the first game and loses the second game is this. 5 times 7, 35. Again, out of 72. They're all going to be out of 72 because we're timesing 8 by 9 on the denominators. The probability she will lose at least one game. So now we've got to add these 3 probabilities together. So we're going to add 35 out of 72, 6 out of 72, and 21 out of 72. And these all add together to give us 62 out of 72. Okay? Because they've all got the same denominator, we can just add the numerators. Now this will simplify. Never bother with probability. There's no marks for it and you could go wrong. Some of you may be thinking I've done this the long way. I did. The quicker way of doing this was to do the opposite. So we could have figured out the probability she wins both games. So 5 out of 8 times 2 out of 9, which is 10 out of 72. In doing that, we would have known what was left over was 60 out of 72 and saved us doing all the other work. So sometimes with probability, it's worth working out the opposite of what it's asking you, and you can use it to figure out what they're asking. So either way is fine there. Question 13. So we've got y is directly proportional to x. And again, on this hint paper, I've kind of written y is proportional to x here. That's the proportion symbol. Now, y doesn't equal x. There's some constant of proportion. We have to times x by something to make it equal to y. And the constant for proportion, we use the letter k. So I've written y equals kx. And what we always do in these type of questions is we substitute in the two numbers we're given. So we're told y is 24 and we're told x is 1.5. And what we can do now is rearrange this to figure out what k is. K is going to be equal to 24 divided by 1.5. Now I would always double both numbers so that I can do 48 divided by 3. And I know that 3 goes into 48 16 times. Now I can rewrite my formula. Instead of y equals kx, y is equal to 16 times x. So that's the relationship here. Y is always equal to 16 times whatever x is. So work out the value of y when x equals 5. Well, y equals 16 times 5. 16 times 10 is 160. So halve that to figure out what 5 of them are. It's 80. So y equals 80. Lots more questions like that on my website. If you want to practice direct and inverse proportion, just have a look at the description. You'll find a link to my website. I've got loads of worksheets on different questions. And now we're going to do 1/16 in the form 4 to the power of n. So this is fractional indices. What we need to be aware of, 4 squared, 16. 4 to the power of 1 is 4. 4 to the power of 0 is 1. As we're going down in powers, the numbers are getting 4 times smaller each time. So if we go 4 to the power of minus 1, that 1 gets 4 times smaller, so it becomes a quarter. And 4 to the power of minus 2 is 1/16. So 1/16 in the form 4 to the power of n is 4 to the power of minus 2. Quite a tricky one, that, for 1 mark. And then 8 to the power of 5/3 take away 9 to the power of 3/2. So I've broken this down into 2 stages. What we need to know is that this 3 on the bottom of the fractional power means you apply that root. So we're going to apply the third root to 8 first. And the cube root of 8 is 2. And now we're left with 2 to the power of 5. 2 to the power of 5 means that you multiply 2 by itself 5 times. So we got 4, 8, 16, 32. So in a minute, we're going to do 32, take away whatever 9 to the power of 3/2 is. Again, deal with the bottom of the fraction first. This fractional power, the 2 there means you square root. So we're going to square root the 9, which is 3. And then we're going to deal with the 3 that was on top now. That means we cube 3. 3 times 3 times 3. Well, 3 times 3 is 9. Times that 9 by 3, and you get 27. So now we've got this question to the point where it's just 32, take away 27, which is 5. Again, some hints here. So for question 15, we need to be confident on the equation of a line, what the gradient is, and also how that affects a perpendicular line. So a perpendicular line is a line at a right angle to the line we're already looking at. Now in red here, I've put y equals 2x minus 5 for line 1. So the gradient, if it's in the form y equals, is always the number in front of x. So the gradient of this line is 2. What that means is for every one you go along on the x-axis, you'll go up 2 on the y-axis. It determines the steepness of the line. Now a perpendicular line will be going this way, and it won't have the same gradient, but it's related to the gradient of the red line. It has to be negative because the other one's positive. If you get two lines that are perpendicular, one's gradient will be positive and the other one will be negative. And what we can do with that 2 now, it's not -2, but if we get the reciprocal of 2, which kind of means flipping it over, it's a half. So the perpendicular gradient is -1/2. So find the reciprocal of the gradient you already know and change the sign. If it's positive, it becomes negative and vice versa. So we're told that the equation of line 2 is 6y plus kx minus 12. Okay, now we need to rearrange that line. We need this line in the form y equals mx plus c. So 6y plus kx minus 12 equals 0. The reason we want it y equals is the gradient is only the gradient and is only the value in front of x when it's y equals, when it's in that form. So I'm going to bring everything to the other side. So the -12 becomes +12. And when we take the kx across, it becomes -kx. And the final step here is to make y the subject. So we've got to divide everything by 6. So we get -k/6x plus 2, because 12 divided by 6 is 2. Now what we can do, this is quite a tricky question, is put the -k/6 equal to -1/2. So -k/6 equals -1/2. Well, therefore, positive k/6 is +1/2. And to figure out what k is, we need to multiply both sides by 6 to get rid of the divide by 6. And 6 times 1/2 is 3. So k equals 3. Quite a tricky question there, even if you generally get this topic. Still quite hard to get to k there. Moving on to question 16. And we're given this formula, you're not expected to know it. Any formulas that appear on the question paper in a rectangle are given to you. And this question is about surface area. So we're told 3/8 of the surface area is 75 pi. So what we could do there is say, well, 1/8, to get from 3/8 to 1/8, we divide by 3. So we now know that 1/8 of the surface area is 75 divided by 3, 25, and 25 pi. Okay? And from here, because we now know what 1/8 is, we could actually figure out what the whole surface area is. Again, I've put some hints here. If you were struggling with this on your own, it might guide you if you were attempting my hint paper. So to get the whole sphere, which is 8/8, because 8/8 is a whole in this case, we're going to times that 25 pi by 8, or 25 times 8 is 200 pi. So the whole surface area is 200 pi. And now what we can do is use the formula we were given. So we were told that the surface area is 4 pi r squared. And we can put that equal now to our 200 pi to find the diameter of the sphere. So we can use this to find the radius. We can make the radius the subject, and then we can use the radius to find the diameter. We'll just double it at the end. And we're being told, we're given a clue that it's going to end up in a surd form. So the first step we can do, we zoom right in on this. You can always divide both sides by pi and just sort of cross it out. So we can go straight to 4r squared equals 200. We can then divide both sides by 4 to get r as the subject, or r squared as the subject. And actually what we want to do next is get r as the subject, so we would square root the 50. And it's kind of given us a clue that this surd will simplify because we've got a root b. So we need to be looking for a square number that can multiply to make 50, and that square number is 25. We can break surds up like this into two surds that times to make root 50. And the point of that being that the square root of 25 is 5. So it becomes 5 times root 2. We put 5 root 2. Really tempting to finish here, put that as our answer, but it wants the diameter of the sphere. Well, a diameter is 2 radiuses, so we would times the 5 root 2 by 2 to give us 10 root 2. And then we've got making x the subject, which is kind of what we just did. We just made r the subject on question 16. A few things we can do here. Even if you were like, I'm not going to be able to do this, there's often like a mark for expanding the bracket on top. So let's just do that. 4 times 2x is 8x, and 4 times 7 is 28. Because it was minus 7, it's minus 28. And we got 5x plus 3. So we now need to know what to do here. How do we get rid of this 5x plus 3 from the bottom? We never really want fractions when we're rearranging a formula, particularly as we want x as the subject. So what we can do is times both sides by 5x plus 3. What that does to the right is it just gets rid of divide by 5x plus 3, but we have to times the left by 5x plus 3. This is where brackets comes from, because we have to do y times all of 5x plus 3. And again, if we expand this bracket, we get 5xy plus 3y equals 8x minus 28. So we're slowly getting there. We still need to get x as the subject. And when you do these kind of ones, you kind of need to be aware of what we're going to have to do in a minute. We're going to have to factorize to get x out as the subject. When I work with students, when they know that's what they're meant to do, they do it. If they don't know what that's meant to do, they don't do it. So knowing what you've got to do here is really helpful. So I'm going to bring the 8x across, so it becomes minus 8x. I'm actually going to take the 3y across at the same time. So I'm going to take away 3y from both sides to get that. So x still isn't close to being the subject here. This is where we're going to factorize, like I was just on about. We take x out as a factor from both parts. And then the final step is to get x as the subject, we divide that minus 28 minus 3y by 5y minus 8. So these are called, I mean, the term for these is like factorizing, not factorizing, rearranging harder formula. There's more worksheets like this on my website. There's loads available on Maths Genie and Corbett Maths, but on my website, Maths Links, there's links to all those. And when you know that's what you're meant to do, you generally can end up getting there. It's just practice. So go and have a go at some more questions like that if you're struggling. Question 18 here. We've got the cost of 7 kilograms of carrots and 5 kilograms of tomatoes. And we've got a ratio here. So I've tried to use the colors here to sort of unpick what's going on. Cost of 1 kilogram of carrots, the cost of 1 kilogram of tomatoes is 5 to 9. So tomatoes are more expensive than the carrots. And what I've written here is I've used x to represent the cost. So 7 kilograms of carrots means we've got 7 times 5x. Because it's 7 kilograms and the cost of 1 kilogram is 5x. So that's 35x. And for 5 kilograms of tomato, we do 5 times 9x, which is 45x. The total cost of those in terms of x is 35x plus 45x, which is 80x. And we were told that the overall cost was 480p. So we can put it equal to 480 and we can divide both sides by 80. 8 goes into 48 6 times, 80 goes into 480 6 times. So we've now figured out that x is 6. So we can go back to here and say, right, 5 times 6 kilograms of carrots is 30p, and 9 times 6 kilogram of tomatoes is 54p. And it doesn't seem unreasonable. That might be cheap for carrots and tomatoes, but it's not like we got 800 pence a kilogram or something. So it's a bit of a guide that we've probably done it right there. And question 19, after a few hard questions, this one's fairly easy, of course, if you know what you're doing. If you don't know what you're doing, it's not easy at all. It's called the product rule. We're going to times, with the product rule, you times the combinations together to figure out how many combinations there are. We're told there are 5 starters, 12 main courses, and X desserts. There are 420 different ways to choose a starter, a main, and dessert. So that would come from doing 5 times 12 times X. We would times the combinations together, and we're being told there are 420 of them. So we've got a little equation here. We can times 5 and 12 together to get 60. So we've got 60x equals 420. To figure out what x is, we divide 420 by 60, which is 42 divided by 6, which is 7. So there must be 7 desserts. And things we could do right here now to check is we could do 5 times 12 times 7 and see if we get 420. We do, but obviously if you're in your exam, it might be worth doing that just to feel confident that you've done it right. And now question 20. We've got functions, which is never a topic people love. And I've written here, the negative one, power of negative 1 means inverse function. So it's the opposite of this function up here, which they've called g. That function says you've got a square root x, add on 2, and then divide by 5. Now the inverse function will always involve the opposites of that. So it's going to involve timesing by 5, taking away 2, and squaring. Now some people can look at these and just say what it's going to be. The method here is we use y instead of the g of x. And we rewrite the formula down here. And then you swap x and y over. So you say x is equal to the square root of y plus 2 divided by 5. Feels like a weird method. The idea here is we're now going to make y the subject again. And in doing that, we invert the function. We turn it sort of inside out on itself. And this will be the inverse function. I've not left myself a good amount of room here, so I'm going to go up to the top right. So first step would be to times by 5 to get rid of the divide by 5. I would then be tempted to swap over as I take away 2. So 5x take away 2. And the final step to get y as the subject is we need to square. So it's 5x minus 2 squared. So the inverse function is brackets 5x minus 2 squared. It doesn't need us to expand that. If you did expand it, it wouldn't be wrong, so it'd be fine, but we can leave it like that. Now question B, there's a few ways of doing this. We can actually use the inverse function we just got here, because what the question's asking us is what value of x can you put into f and then into g to get 3? So what you can actually do is put f into the inverse function of g and then into the inverse function of f. So we can put 3 in. So 5 times 3, take away 2, squared. So 15 take away 2 is 13. 13 squared is 169. Now we can put this 169, I'm actually going to change the color, I don't know why I'm in yellow. 169 into the inverse function of f. So the inverse function of f will be, instead of timesing x by 3 and adding on 4, we would take away 4 and divide by 3. So we can put our 169 in there, and we get 165 divided by 3, which is 55. So that is one way of doing it. The other way to do this is we create the composite function, and because f is closest to the brackets, we're going to put the f function into g. So we're going to put that 3x plus 4 inside the square root that's in g, and then build the function of g around it. And what we can do, we know this equals 3, so we've got an equation here. So we can now solve this. Now I'm going to go below this line here to solve it. Don't do this in the exam because it gets scanned in. And they'd be looking for your working out in the scanned area. but I'm going to do it for this purpose. So to rearrange this, we need to get rid of the divide by 5. So we times by 5. So we get 15. To get rid of that plus 2, we take away 2, which gives us 13. And kind of we're going to see that 169 now. When we square both sides, we get 169. We take away the 4 like we did a minute ago. And then to get 1x, we divide 165 by 3, which is also 55. So 2 ways of doing it. Probably the second way that I did in blue might be the way you'd be expected to do it and you'd probably feel confident to do. So that's composite and inverse functions. It's quite a tricky topic. You've got to practice it really to get used to it. You can't just have a go at it a couple of times and understand what you're doing. So lots of work needed there. Question 21, circle theorems. There's some highlights on here just to make it clear what we need to do. We're being asked to find angle ADC. So it's the yellow angle. And there's some colors on here to help us. So straight away, angle BAD would be the same if we put A up here. So if A moved to up here, it would be the same. And we get this arrowhead shape. Badly drawn. Let's draw it again. So if we moved A to up here, we'd probably see then, if you're good at circle theorems, you'll know this angle is half of the angle at the center. So BAD is 32 degrees because angle at the center is twice the angle at circumference. And they wanted reasons. So we've got to write down any circle theorems we use, because angle at the center is twice angle at circumference. Kind of hard to spot that one. It looks a bit like angles in the same segment are equal. I'm actually going to take this back off so we can see what's going on. We can now figure out the green angle, because we know this angle in here is 32. We know the 51 degrees as well. So we can figure out the green angle because angles in a triangle add up to 180. So 83. So the F angle is 97. And it says write down any circle theorems we use. So we don't have to write angles in a triangle add up to 180. You can do if you want to. So this is 97. This here is also 97. Those two are vertically opposite angles. And again, now we can figure out the blue angle because of angles in a triangle. 97 plus 64. When we add those together, we get 161. So the blue angle must be 19 degrees. And now we need to know that the angle between a tangent and a chord, a tangent and a radius, is 90 degrees. So ADC is 90, take away 19. This was 19, let's put that in. And let's say angle between a tangent and a radius is 90 degrees. I mean, that's the definition of a tangent, that it's at 90 degrees to the radius, and it only touches at one point. Angle between a tangent and a radius is 90 degrees. So lots of rules there on angles, 2 circle theorems, the ones I've written down, so I didn't write down the other rules. And here we've got, straight off we should be thinking Pythagoras or trigonometry in 3D. We've got 2 sides. I've drawn in this right angle triangle. I've sort of put in the information we've been told that AF is 6.8. Well, that should be in green. Put that in green. AF is 6.8. And FC, the sort of diagonals of the cuboid, is 13.6. I'm being asked to work out the size of the angle between FC and the plane ABCD. The plane ABCD just means the sort of bottom of the box. So we literally need to figure out the angle I've put here in red. I've put theta there to represent it. So actually, once we spot this, it's just a little bit of trigonometry, right angle trigonometry. We label the sides. So the 6.8 is opposite the angle, it's the opposite side. and the 13.6 is the hypotenuse. I don't bother to label the adjacent because it helps me to spot that this is sine we're using. I like to do trigonometry in a formula triangle. SOHCAHTOA helps me remember how to put them in the triangle. And we're being asked to find what are we being asked? We're being asked to find theta. So no need to rearrange it, apart from to get the angle, we need the inverse function. So the inverse function of sine. So we're going to substitute in the two values we know and then think about this because we haven't got a calculator, have we? So maybe a bit trickier than I thought. What I'm expecting is that this fraction simplifies down to something nice. Probably a half looking at it, and we're expected to know what the inverse function of a half is here. So let's just check this is a half. Yeah, 6.8 is half of 13.6, so it's a half. And the inverse function of a half is 30 degrees. That's the angle. So 30 degrees there. If you don't know your trig values, time to start learning them. Not essential, you can get away with not knowing them. It doesn't always come up, but worth knowing because it'd be horrible to not know what to do here. Just double checking I got that right on the mark scheme. Always do that when you're working. I did get it right. And question 23, we've got some surds here. I've used the red to highlight the first one. We're just going to try and tidy that up a little bit first. So to tidy this up, we need to rationalize it. And what we need to know is when we get, firstly, what rationalizing the denominator means. It means we're going to get rid of the surd on the bottom. To get rid of the surd in this case, we've got to times the bottom by 4 plus root 3. So almost the same as what's on the bottom. This is using the difference of two squares. When we do this multiplication, it's going to get rid of the surd on the bottom. And then we're going to times the top by 4 plus root 3. Because whatever you do to the bottom, you've got to do to the top to maintain it being the same fraction. So we've got 3 root 3 times 4 plus root 3. And then we got 4 minus root 3 times 4 plus root 3. And we're going to expand these brackets. So we get 12 root 3. Root 3 times root 3 becomes 3, and we got that extra 3 there. 3 times 3 is 9. Now when I multiply the bottom, the whole point of this is that it's going to get rid of the surds. And once you do enough of these, you realize you only need to do the front 2 times the back 2. So 4 times 4 is 16. Root 3 times root 3 is 3. 1's negative, so it makes the answer negative. So we get 12 root 3 plus 9 over 13. Okay. Now the second one's much easier to rationalize. To get rid of that root 3, we just times by root 3. So if you times a surd by itself, it's no longer a surd. So root 3 times root 3 is 3, and 2 times root 3 is 2 root 3. So now we've got these two fractions, and we need to do a subtraction. To add or subtract two fractions, we need them to have a common denominator. So the lowest common multiple of 13 and 3 is 39, which comes from multiplying 3 and 13 together. So we would need to times 13 by 3, so we need to times the top by 3, which gives us 36 lots of root 3 plus 27. And for the other fraction, we'd need to times top and bottom by 13. And 13 times 2 is 26, so it's 26 root 3. Now we can just do the subtraction. We end up with 36 root 3 take away 26 root 3, which is 10 root 3. and then that 27 just remains, and all of that is over 39. And we can't simplify this. There's no numbers that go into 10, 27, and 39 other than 1, and that's not going to help. So that's our answer. Question 24, quite a tricky one, this. Again, you can see what I've sort of put here. This was on my hint paper. To do these kind of questions, we've got quadratic inequalities. You need to, first of all, know how to solve quadratic equations, and then it's learning the next steps. So the one on the left, I've put, it needs to go into double brackets. This is a difference of 2 squares, so you need to get used to spotting that. 4x squared is a square number. 2x and 2x times to make that, and 5 and 5 times to make 25. For this to work, 1 is plus 5 and 1 is minus 5. And that gives us 2 solutions. Here for this one, minus 2.5. For this one, x needs to be 2.5. And the roots can be drawn on the graph. And what this would look like, this quadratic equation when graphed like this, where is it less than 0? Well, it's less than 0 underneath the graph. So the solutions to this are x needs to be between minus 2.5 and positive 2.5. So those are the values of x that if we substitute them in, we'd get less than 0. If we do the same with the green one over here, 3x squared, if we factorise it, one bracket's going to have 3x in it, the other one's going to have x. And then we need to think about this because whatever number goes here is going to get multiplied by the 3x. So that affects how we think about this, how we factorise this. And we need 3 to go there and minus 4 to go here. This expansion gives us plus 9x. This gives us minus 4x. Overall, that gives us plus 5x. So the two solutions here, x is minus 3 and x is 4/3. I didn't talk about this, but I had rearranged that inequality at the start. I'd made it so that the inequality symbol had changed the other way, so I changed the sign of the 3x squared, the minus 5x, and the plus 12. It makes it easier to factorise, and also the good thing about this is because it's now positive 3x squared, it's going to graph like this. So again, we're looking between the two values, so we've got here x is minus 3, here x is 4/5, and again we're looking for where is it less than 0, so again it's under the line, so it's between the two values of minus 3 and positive 4/5. Okay, now I could draw these on the number line. So we've got 4/5 here. So this is the one we just did. It's between these two values. We don't colour those circles in because it can't be equal to those two values. And if we draw on the other one, it was between minus 2.5 and plus 2.5. And overall, the values that satisfy both inequalities exist here. So x can be between minus 2.5 and positive 4/3. That was 4/3, wasn't it? I've written the wrong number in the whole way. So that should have been 4/3. Let me go back and change that. 4/3. 4/3. Okay, so I have that slightly wrong because it's positive 4 divided by 3. So those are the two inequalities solved, and the blue bit represents what satisfies both inequalities. So that's that there. Okay, so that's the paper done.